Imagine your smart contract making decisions, just like a human choosing an umbrella or sunglasses. Conditional statements, the if, else constructs. Let your code branch based on conditions. Think of them as traffic signals guiding the flow of your program. In Solidity, these work much like in JavaScript or C. You check a condition in parentheses, and if it's true, the code inside the block runs. This is fundamental to smart contracts, because it lets your contract react differently depending on inputs or state, enabling dynamic behavior. For example, a contract can check if a user is old enough to vote, has enough balance to spend, or if a number is even or odd, and take different actions accordingly. Conditional statements follow a simple structure. If condition, this block runs only if condition is true. Else if, condition 2 checked if the first if was false, and runs if condition 2 is true. Else runs if none of the above conditions were true. Together, they allow one branch of code to execute depending on which condition holds. If none of the if or else if conditions match, the else block is the fallback. Think of it like checking weather. If it's raining, take an umbrella. Else if it's sunny, wear sunglasses. Else carry on normally. Each of these decisions corresponds to an if or else if clause. Solidity's if and else syntax enforces Boolean conditions. There are no tricks like if one. Conditions must be comparisons or expressions evaluating to true or false. For example, each part is optional. You can have just an if, or if plus else, or if plus multiple else if plus else, but they must appear in that order. This structure is the same as other programming languages, making it easy for beginners to pick up. Conditional logic is critical in smart contracts. It lets contracts enforce rules and make choices. For instance, you might only allow a token transfer if the sender has enough balance, or only let a function run after a certain date. Conditional statements allow smart contracts to execute code based on specific conditions, enabling dynamic responses, as one Solidity guide explains. Without conditionals, a contract would run the same code path every time, with no flexibility or security checks. How if, else if, and else work? Let's break down how these parts work in Solidity. If condition, this is the first check. If condition is true, Solidity runs the code block immediately after it, and then skips the rest of the else if, else chain. Else if, another condition. If the first if was false, Solidity checks this next condition. You can have as many else if clauses as you need. Solidity evaluates them in order until one is true. Else, if no previous condition was true, the else block runs. This is the default case. It has no condition. For example, in Solidity you might write, this checks each range in turn. The first true branch is taken, and the rest are skipped. The keyword else if is just an if inside an else, so the code reads naturally as else if another condition holds. If none of the if or else if conditions match, the else block is the fallback. Note, Solidity requires the condition inside if to be a Boolean. You cannot write if 1 or if 0, like in some languages. You have to use comparisons, like x equal to y, or logical expressions like must be is member imbalance is greater than 0. Why conditionals matter in smart contracts? Smart contracts often need to enforce rules and adapt to inputs. Conditional statements are how you embed these rules. Enforce rules like, if the sender is the owner, allow this action, else revert. Handle different cases like, if a sale is still active, accept bids, else refund the bidder. Perform validations like, if the user's balance is sufficient, proceed, else throw an error. Think of a conditional as a branch in the road. The contract checks a condition and takes one path or another. Without them, a contract could not differentiate between valid and invalid situations. As the Solidity docs note, control structures like if-else work just like they do in other languages, but here they help your dApp safely handle different scenarios. For a real-world analogy, imagine a robot programmed to respond to weather. The code might read, if weather is rainy, wear umbrella. Else if weather is sunny, wear sunglasses. Else, continue normal. This is just like our code. The robot checks if it's raining. If not, it checks if it's sunny. Otherwise, it does the default. This is exactly how if-else chains work in Solidity and any other language. Example 1, checking user eligibility, age, or role. Let's see a practical example. Suppose we have a function that checks if a user is eligible based on age or role. For instance, a voting contract might want to ensure voters are 18 or older. We could write a function that checks eligibility. This code does the following. If the age is less than 18, it returns a not eligible message. Else if age equals 18, it returns a special message. Otherwise, else, the user is older than 18 and is eligible. In plain English, this says, if age is under 18, do X. Else if age exactly 18, do Y, else do Z. The first true branch stops the chain. This example is drawn from a smart contract sample and illustrates if, and else in action. You could imagine a similar check for roles, for example. If user role is equal to admin, do something else something, to give special permission to admins. Another way to do a simple age check is to return a Boolean, Another function is whoCanVote. It's take a number and returning a bool, true or false. If age is greater than 18, return true. Else, return false. Here we only used if and else, no else if, because there were only two outcomes. This matches a common Solidity example. The function returns true if the age condition is met, otherwise false. Next, imagine you want to compare account balances or check thresholds. For instance, an app might classify users as high spender or normal user based on their balance. Here's a simple function illustrating that. In this snippet, the code first checks if balance greater than 1000. If so, it returns a message for high balances. If not, it checks balances greater than 100. If that's true, it returns a medium balance message. Otherwise, else, the balance is 100 or below, and it returns a low balance message. This shows how you can stack else if clauses to handle multiple ranges or comparisons in a smart contract. You could also compare two addresses' balances. Like a function that compares to address, here we simply used an if and an else. If one user's balance is higher, we do one thing. Otherwise, including the case they are equal, we do the other. Each condition controls the contract logic clearly. Last example. A classic beginner example is checking if a number is even or odd. In Solidity, this might look like, here we use the modulo operator. The condition x divided by 2 equal to 0 is true when x is even. If it's true, the function returns true. Otherwise, the else branch returns false. This could also be written with an else if explicitly, checking x divided by 2 equal to 1 for odd. But here one if and an else suffices. In VoiceOver, you might say check the remainder when dividing by 2. If it's 0, the number is even. Otherwise it's odd. Notice that in each example the syntax is the same. If, this, do something, else if, and else. The conditions age is less than 18, or balance is greater than 1000, x divided by 2 equal to 0, etc. determine which block runs. Solidity's semantics here are identical to many other languages, so if you've seen if statements elsewhere, this will feel familiar. Let's recap what we've learned. Conditional statements, if, else, let your smart contract make decisions based on conditions. They execute code blocks only when their condition is true. Use if condition for the primary test, else if, condition 2 for additional checks, and else as a default case. Solidity follows the same syntax as JavaScript or C-style languages. In smart contracts, conditionals are crucial for logic like authorizations, input validation, and dynamic behavior. They are the traffic lights of your code, guiding what happens when different scenarios arise. We saw examples: age role checks, voting eligibility, balance comparisons, and even odd checks. Each uses if-else to direct the flow. Only the branch with a true condition runs. Now that you understand the basics, try writing and testing these examples in the Remix IDE. Contract with if-else statements, tweak the conditions, and see how the output changes when you call the functions. Experimenting is the best way to solidify your understanding. If you found this explanation helpful, don't forget to subscribe to stay updated on more Solidity and blockchain tutorials. Happy coding!